Hi everyone, I'm Lorraine Driscoll, and this is another episode of Building Better Brains, where each week I talk about the root causes of why your child might be having a hard time learning, reading, and behaving, and what are some solutions that reach way beyond limitations of IEPs, medication, and endless tutoring. Last week I talked about the corpus callosum and how that can affect emotional regulation and so forth, like in terms of attention and focus. And today I want to talk about how that rich band, or should be a rich, thick band of neural fibers between the right and left brain hemispheres, how that can impact learning and reading whenever those signals are not being transmitted efficiently or effectively across that band from the two opposing hemispheres. So obviously we know that, or should know, right? It's pretty straightforward. I think that both sides of the brain are utilized or necessary for learning. And the left side of the brain, whenever it gets information and learns by repetitively receiving that information, which it then transfers to the right side of the brain. And the right side of the brain stores it into the long-term memory. So let's just chat briefly about what the right side of the brain does. So the right side of the brain is where the visual cortex is and where visual processing occurs, and it's where the long-term memory is. And the left side of the brain is where the auditory cortex is, and it's where the short-term memory is. So you can see why both of these sides of the brain need to work very efficiently together in order for information to be, or even, let's just put it this way, in order for learning to occur well. So reading and language in general occur with both sides of the brain. Reading is more of a left brain activity, which I'll get into in a bit. But in general, the right side of the brain with language is responsible or picks up on the nonverbal cues, the body language. It detects like the emotional aspects of language and processes the meaning of words and uses expression and so forth. Whereas the left side of the brain, if we remember from last week, is more logical and decodes sounds, uses and understands tone, and even is responsible for like the sequencing and timing of letters. So you can see why when it comes to reading, that can be really important, that that's working efficiently and getting good information from the right side to be able to do that job. So let's talk about weak memory as well, because those two sides of the brain, the left does the short and the right does the long-term memory. And memory is often a huge part of learning difficulties as well as reading difficulties. So when there is difficulty transferring information from left to right or vice versa, you're obviously going to have memory issues. So the information, like I said, is stored in the short-term memory on the left whenever there's issues, instead of being transferred to the right side where the long-term memory is. And so this is why you're going to see kids who are struggling and saying that they can't remember, or you feel like I just explained this to you, or I explained this to you yesterday, why aren't you retaining it? It's not really, it's only going into their short-term memory. It's not going into their long-term memory. And this happens because that corpus callosum is acting as a barrier rather than a bridge. And this disconnection happens because this band of neural fibers is not thick and well developed. And that can happen for all kinds of reasons, which I'll get into in a minute. But just to go back to, when it's not developed, it's not acting as a bridge, it's acting as a barrier. And also it's not doing its job as a filter to kind of balance those two brain hemispheres. So when there is an imbalance or challenges with that, learning a language or learning to read can become way more challenging to next to impossible. And so whether it's speaking, writing, reading, and so forth, this is where you're going to have difficulties with speech, possibly with writing, being able to write in terms of processing what you're trying to say and get the fine motor skills to work at the same time, as well as doing the language aspect of writing with the phonics and sounding all the words out and so forth, if it's not automatized. And then when it comes down to reading, difficulty can happen with the phonics, with recognizing symbols, with blending sounds, and again, just getting those ideas on paper if we're writing. So basically, when that filter is not working well, when that bridge is not working well, information's not crossing well, your child will have or has a disorganized brain. So there's parts of the brain doing the job that it's really not supposed to be doing. So as I've mentioned before, the language center is on the left side of the brain. That's what is generally weak in children who have reading disorders and dyslexia. But reading is a two-hemisphere process. It's not that it's just the left, because the visual cortex, as we know, is on the right side, right? So let's kind of just break this down really simply in terms of reading. So in terms of reading, what happens in the left hemisphere is that's where the auditory center is, the auditory cortex is, and that's the part of the brain that's going to blend sounds, analyze thoughts, sequence time, and so forth. The left side of the brain, where the visual center or cortex is what's going to recognize those symbols, those letters, and recognize them accurately, right? If there's issues there, then we're going to end up with the reversals and so forth. And also to be able to visualize the story and place it into the long-term memory so that they have reading comprehension. And this side of the brain, the right, is also what picks up on the sight words and memorizing those sight words and retaining them and so forth. So dyslexia is known as a phonological deficit, a phonemic deficit as it's traditionally defined. And that has to do with the auditory cortex, which is in the left side of the brain. And this is why dyslexia is often viewed as a left brain deficit. And these kids tend to be really right brain dominant. These are the kids who have excellent visual spatial skills often. They can be really good artists. They're very mechanically minded. They're really good at building or fixing stuff. So sometimes they can have really good long-term memory depending on if there's other weaknesses, but if they don't have other weaknesses, their long-term memory can be really good because there's that whole right brain dominance. But it really depends, right? It's never just usually one thing. And so what's interesting is that the right side of the brain is the first side to develop. And if there's impediments to that corpus callosum developing properly, then there's not going to be efficient communication to the left side, and children can end up with a right brain dominance. And certain factors can affect that band of fiber from developing in infancy. Toxicity is definitely one of them, but missing milestones is definitely another. So what can happen as a result of the corpus callosum being weak or underdeveloped is reversals, poor visual motor skills, poor focus. The list can go on and on. Like I've seen kids with problems with everything from ADHD, sensory processing, to reading and learning difficulties. And basically when the bridge is working well, when that band is developed and thick, this is what manages and directs eye movement that we need for efficient and effective reading. So very important that we work on that if it's not developed. So one of the big milestones that I would say 90% of my clients, the parents will tell me, he hardly crawled, he barely crawled, he was an early walker. He had a weird crawl, it wasn't what we call a well-developed crawl. And crawling is that cross-lateral movement that helps to thicken, or crossover movement, I should say, that helps to thicken that corpus callosum. It is the early infant movements that develop the motor system that develops the brain. And if those early or lower brain levels are not efficiently developed, then the higher brain levels are going to be compromised. And it's those exercises that essentially builds that bridge so that that corpus callosum is acting as a bridge and not a barrier. And so when there are learning disabilities, it is very, very common. One of the biggest factors with it, aside from the whole nutrition and gut and everything else, is that those signals are not being efficiently transmitted across the corpus callosum. You have something that's like not a complete barrier, like nothing's getting across, but not getting across very well. And as we develop that corpus callosum with brain integration therapy, that can, like you can see huge rewards or benefits or results from working on it. And so that's what brain integration therapy is it's exercises that simulate the early movements that infants do. Whether it's movement or cognitive exercises, I do both with my program. And that improves the connectivity and communication between the left and right brain hemisphere. And so it's a series of exercises that simulate, like I said, the early motor movements, so that even if your child misses those movements, and it doesn't have to do, like sometimes they did crawl, but there's other factors that can affect it. Even a head injury can affect the brain development and so forth, and it doesn't have to be that severe. So just keep that in mind, not to like feel like that's the end of the story and to get discouraged. There's lots we can do to improve that connectivity and help children to learn more efficiently and optimally, as well as self-regulate. So if you found this helpful, please share, and feel free to hop onto my website to check out my articles. And if you want, book a free 20-minute Better Brains consult to learn more about what I do, how I could help your child, and my programs. And yeah, thanks for watching.